through 4 was on your very, very first quiz on exponential solving equations because it's that one-to-one property. So I didn't want to miss hitting on kind of the easy ones. We could solve any of these 4 problems without needing to know anything about logs, right? Because if the base happens to be 3 on both sides, I know that this exponent has to be equal to this exponent. So I'm just going to solve the linear equation that 6x plus 1 has to equal 4x minus 1. So I'm just going to get all my x's on one side and solve for x. Right? So I would subtract the 4x to the other side. That would give me 2x plus 1 equals negative 1. Subtract the 1 to the other side, so 2x would equal negative 2. And divide by 2 on both sides, so x would have to be just negative 1, would be my answer. So I didn't need a log at all. All I needed was that one-to-one property, right? So always start by looking for the one-to-one property, because you might be able to do it without a calculator. So what's the problem on number 2? Number 2, they don't have the same base. So a lot of the ones we see today are not going to have the same base, but this comes from the same power family, right? They both are a power of 2. So the one on the right, I could rewrite as 2 squared, because then I haven't changed the value to the x power. So this is a good review of your exponent properties. When you distribute, you can multiply your exponents. So this is really 2 to the 2x is equal to 2 to the x plus 7. So now I'm in the same situation as number 1. So go ahead and set your exponents equal and solve for x. And then why don't you try 3 and 4 the same way? So see if you can finish 2, 3, and 4. Shouldn't really need it where you have to change both of the bases on both sides. Oh, I kind of did it as 2 steps. Like I added this negative 1x to the other side, made this a 3x, and then I subtracted the 8 because this is an x and this is a constant. So I kind of did it in, I added the x to this, got 3x, and I subtracted the 8 over here and got negative 8 as a constant. So then I divided by 3 in my head and I got negative 8/3. I just didn't have enough room to like write out every step separate. Yeah. So that's called the one-to-one property for exponents. So if you have a question that's on, part 1 of your test, which is no calculator, you're going to be looking for that property. Same thing with 5 and 6. There's the one-to-one property also for logs. If you notice, you've got the base 3 on both sides of the equation for your log. So then this x and this 7 are in the same position. So x has to be 7, right? That's called the one-to-one property for logs. And you can't really see it on number 6, but if you put that natural log of 3 to the other side of the equation by adding it, you would have the natural log of x equal to the natural log of 3. So now you can see, I think, that x would have to be 3 to make it true. And if there was an equation inside, you could just set, just like up here with exponents, you could set, if you had the log of x plus 8 equals the log of 2x minus 9, you could just go ahead and set this inside piece equal to this inside piece and ignore the logs because it's the one-to-one property. All right, so what happens when we can't use the one-to-one property? This is why we learned logs in the first place. I see a 2x or 2 to the x and I see a 10, and those do not come from the same power family. So up until today, there's no way to do this problem besides guess and check. I know that 2 cubed is 8 and 2 to the 4th is 16, so my answer is between 3 and 4, but I would have to guess and check on my calculator. 2 raised maybe to the 3.5 power. Oh, that's too big, that's 11. 2 raised to the 3.2 power. Oh, that's pretty close, that's 9.18. So here's how you do it if you don't want to guess and check. We transform this. I've done these steps in the past. I'm just going to transform it into log form, but isolate the exponential expression, take the log of both sides is really change it into log form. So anytime you don't like your exponential equation, change it into a log equation. The base of the log, right, is going to be the base of the exponent. And then remember the exponent gets freed up and the solution gets sucked inside the log. So the log base 2 of 10 must equal x. This is easily evaluated using your calculator. And now I have something I could type into my calculator to get the exact answer without having to guess and check. So that's under the math key. So this would be a calculator question. This is the problems that you're doing on the homework tonight. I just have to do the log base 2 of 10. And voila, my answer is 3.32. So I would have to guess and check for a while to get that to the nearest hundredth. Log form. So you're going to get really good at changing into log form. The base is going to be 2, so log base 2. The 3 moves inside the log, which will free up your exponent x plus 1 outside the log. These are equivalent, right? The base is 2. If I raise it to the x plus 1 power, I get 3, and that's exactly what I started with. When you do this on your calculator, you'll have to finish by then subtracting 1 from whatever you get as your answer, right? To officially get x by itself. So we would do the log base 2 of 3. Oops. Log base 2 of 3. See whatever we get, 1.58, and then still subtract 1 at the end. So was everyone able to get 0.58 as their final answer for x? There's my log, I hit enter, and then I subtracted 1 at the end. Everyone know where this key is? Really important key on your calculator, because on the calculator part of the test, you'll have a graphing calculator, so you can use this key. All right, on number 3, I can't change into log form on 3 and 4 until I have the exponential piece by itself, this piece right here, or this piece right here. So I need to strip away this plus 5 or strip away this coefficient of 4. So on number 3, I would just subtract 5 from each side. So e to the x equals 55. I want to show you this one because it's a little bit special because the base is e. When you put it into log form, right, log base e of 55 equals x. I hope that you recognize you don't have to go to that special key on your calculator. You can just take the natural log of 55 because the log base e is the natural log button on your calculator. So it's kind of weird to write log base e. That kind of looks like you don't know what you're doing. It's fine if you write it that way, but I hope you're being more sophisticated when you type it into your calculator. Use that shortcut key, right? Why go change the base to e if that's what that button does? So you just type the natural log of 55, should come out to 4.01. Does that sound right? 4.01. Anyone need help with that one? So same thing on number 4, we're going to be able to use the natural log button. And to start the problem, you'd have to divide by 4 on both sides. So e to the 2x equals 5/4, or you could write it as 1.25. So you're doing the natural log this time. I want to show this to you like a lot of times when I think it's easier to just change into log form, but you're allowed to take the log of both sides of the equation. When you take the natural log of e, what is the natural log of e equal to? We talked about what the log base e of itself would be. The natural log of e is equal to 1, because e to the first power is e. So if this is equal to 1, the 2x comes down front as a power, and see how you get 2x equals the natural log of 5/4 in one step? But it's fine. If you like just changing base instead of taking the log of both sides, you would write it as the log base e of 5/4 equals 2x, which is the natural log of 5/4 divided by 2 at the end. So when someone says they're going to take the log of both sides, they really are going to take the log of both sides. We're just doing a different strategy. We're just changing it into log form. But it means the same thing. So the natural log of 1.25, and then if I divide my answer by 2, what do I get? Someone type it in and tell me what you get. Natural log of 5/4 divided by 2. 0.11? Yeah. 0.11. Because it was 0.22, and then I divided it by 2 to get 0.11. All right, you try 5 and 6 before we switch gears on the back page and do this in the opposite direction. So these are all, you're starting with exponents, you make it a log. The back page, we're going to start with a log and make it an exponent. And you need to be really good at these steps to solve kind of the application problems we're going to look at. Make sure to use the E button. So E raised to the negative 1/2 power. X would have to be 0.61. I would just always round to 2 decimal places. So use the E, raise it to the negative 1/2 power. So that way, whether we're doing inverses or solving, we're just always changing form. If we start with a log, we rewrite it as an exponential expression. The only thing we're not doing is exchanging x and y, because these are not y equals functions, right? These are equations with logs in them. So there's no x and y to exchange. We're just changing form. All right, in number 2, I'm going to get my log, this whole thing, by itself by dividing by 2 on both sides first. So now I have the log base 6. The 3x is inside the log, even though there's no parentheses, because it's touching itself there. So 3x is inside the log. All right, now I've got the log by itself. I'm going to rewrite in exponential form. This one's actually going to be mental math. I should not need a calculator. 6 is the base, 2 is the power, and the answer is 3x. And I think you should know 36 divided by 3 in your head, right? What is 36 divided by 3? 12. So that was actually, didn't need a calculator, just needed the skill of changing forms. All right, let's try number 3 in the challenge, and then you can try some of those others for practice before you move on to the guided practice on the next page. Make sure we got this skill down. All right, so number 3. I know that I just set up here because the 3x was touching each other. It's inside the log. You can't assume with something being subtracted that it's inside the log. So unless there's parentheses, assume that the negative 5 is outside and it's just the x that's inside the log. Do you see how I put the 2 intentionally in front as a coefficient? I didn't write x times 2. So the 2 is outside the log, the negative 5 is outside the log. So my first step would be to add 5 to the other side. So order of operations, I'm going to add 5 to the other side. That gives me 7. Then divide by 2 to the other side. So that gives me 3.5. So now I'm at the step where I've got the log by itself. I can't figure out what to do next, so I have to switch forms and see if that helps me. So my base is 3 to the 3.5 power will give me my solution for x. So on the calculator, I'm doing 3 to the 3.5 power. So you should get, what does someone get when they did 3 to the 3.5 power? 46.77, I think. I'm just going to round to 2 decimal places just to be consistent. All right, so I think 4 through 8 you guys could try, but let's do this challenge together. So I actually see 3 different natural logs. So it said, here's your hint, combine the natural logs that are on the left using a property. Then it says exponentiate both sides. But we can actually, I think, use the one-to-one property on this problem. So let's see. How do I, if these 2 logs are being added together, what am I allowed to do inside of the log? Do you remember? Adding becomes what inside the log? Multiplication, right. Okay, so this is really the natural log of x minus 2 times 2x minus 3. And then I'm going to rewrite the other side as the natural log of x squared. So I'm going to actually bring the coefficient up into the log, because then I've got the one-to-one property. I've got a natural log of x, and I've got another natural log of x. So that means the stuff in the parentheses on the left has to be equal to the stuff in parentheses on the right. I'm going to drop my logs because they are gone, right? If they're the same on both sides, I can ignore them. And how do I multiply this binomial together? Let's simplify the binomial. So 2x squared, right? And then what? Do my outer plus my inner. This is a challenge, so this would be a good bonus for your test, but multiplying binomials, this is a lot of work. Negative 7x minus 6 equals x squared. This is a good one. You had to use a property, but now you're at solving a quadratic, which we also did this unit, or this quarter. How do I solve a quadratic? What do I need on the right-hand side to get a quadratic? Thank you, yes, plus 6. So what do I have to do next to solve this quadratic? I need to get what on the right-hand side of a quadratic equation? 0. How am I going to get 0 over here? I'm going to subtract the x squared to the left. So now I'll have 1x squared minus 7x plus 6 equals 0, which is a factorable quadratic. Good thing you told me it was plus 6, or it wouldn't have been factorable. Oh, maybe it still would have, but okay. So what does it factor into? This is a good final exam question here, because you've got to do factoring a quadratic, solving, and you had to start with properties of logs. So this is a good pre-calc advanced question. How do I factor x squared minus 7x plus 6? X minus what? X minus what? X minus 6 times x minus 1. Are you with me? Because doing the diamond method, you're looking for the factors of positive 6 that add up to negative 7. All right, these are the factors. So what are the two solutions to the quadratic? Positive 6 or positive 1. So the only thing we solved a quadratic and got two solutions, but a log equation, one of those might be extraneous, which means you got it algebraically, but it doesn't work. What's the domain for any log graph? Log graphs, the x values are always greater than 0, right? When I plug in one of these values, one of these logs becomes undefined. Which one? Is 6 okay? Is 1 okay? Why does one of them fail? 1 doesn't work in the first log, right? Because 1 minus 2 will give me a negative x value in there. So 1 is just considered an extraneous solution. So the only solution to this challenge problem is 6. And I think I put another one of those on either the homework or the team test, where you have to combine, get a quadratic. This was a pretty easy quadratic to factor, in my opinion, because you didn't need the box method for it. And then you had to figure out which of your two was extraneous. All right, you go back and take a step down and try 4, 5, 7, 8, which does not need any properties. And I can check 4 through 8, and then I'd like you to try the next page, 1 through 6. See if you can do all of these, and then maybe we'll take a few minutes to just start on some application problems so that we can kind of move on a little bit. But so number 4 is 3.79. Number 5 is 1 over 100. This would be more of a non-calculator question because it's just 10 to the negative second power. So that's 0.01 or 1 over 100, right? Square it and flip it. Number 7, I'm not going to give you something in scientific notation, but when your calculator says an e that's capitalized, so if I do e to the 40th divided by 2, my calculator gives me this answer in scientific notation. So your calculator doesn't write times 10 to the 17th. It says capital E 17 at the end. Sorry, it's kind of hard to see, but so the answer is actually 1.182 times 10 to the 17th because it's such a big number. So that's 17 decimal places to the right. So I don't even know what that is, more than billions. And then the last one was 28.44. You do 2 to the 8th power, and then that's equal to 9x. So you have to divide by 9 to get the 28.44. I think we did okay on that page. And then some of you just didn't quite get done all of these problems, but maybe if you want to finish them later or try one or two last problems, or it'll be in the video if you want to go back and do them as some review. Number 4 would be a no calculator question on the test because it's just 2 to the 4th power. I think some of you are getting to this step and then you're like, I don't know what to do next. That's the trigger to move to exponential form, or that's the trigger to move to log form. When you're feeling that I'm stuck, I don't know what to do next, that's your cue. Like on number 2, I'm stuck, I can't do anything. That's your cue to move it into log form. First, you check if you can do the one-to-one property, then you switch forms right away. And that's what you're going to use when you're solving some of these application problems. All right, I'm set up, but I can't solve for x. You're going in between the two forms.